So this video contains the work that was covered today for our group. So the first question was this one, which states your father is about to retire. His firm has given him the option of retiring with a lump sum of 20,000 or an annuity of 2,500 for 10 years. Which is worth more now if an interest rate of 6% is used for the annuity? So if you have looked at this question, you have been asked to choose which one is worth more now, right? So most of the time when you've been asked to choose a scenario like this, where you've been told to choose either you select this one or the other one, we have to come and write a certain theoretical statement. You like write it in words that, okay, I'm going to go for this option after making calculations. Just take note of that. So if you look at this question, we have a lump sum that is given to the person today, right? Is being promised a 20,000, or the annuity of 2,500 for a period of 10 years. So now they are asking, are you going to go for the annuity or you just get the whole 20,000 together right now today? So what's going to happen is that, okay, quite right, the 20,000 they've offered you. So now you want to also check the other option, which is the annuity. So the annuity is 2,500, and now you want to bring it to the present. Why the present? Because they said which is worth more now. When you hear that word now, it actually means present value. So just after denoting like that, we know that we'll compute this other one using the present value formula. Is this an annuity? Yes, it is. First of all, they actually even stated it, an annuity, so there's no problem. If they did not state it, we would look for words like each, every, and so on and so forth. Yeah, most of the time, those are the keywords to know it's an annuity. So the formula we're working with is the present value of an annuity. So this is how this question is supposed to be solved. Let me just show you. So we said we're using present value of an annuity. So this is how it's supposed to be. So this is the formula, the general formula. Take note of how I'm writing it. That is how you also need to present this work. Okay. So given a rate and a time period. So what is the annuity? Remember, we're trying to compute this one, which they said 2,500 as an annuity. So the annuity is the same one I just mentioned, 2,500. That's the annuity payment. Then, have we been given a rate? Yes, we have. It was 6%. How about time? Time is 10 years. So what we do is that we go to our table, the PVIF table, go to the part where you find 6% and what else? 10 years. So you got the part where you find 6% and time period of 10 years. So you'll notice that your rates there, they will be in they'll follow a certain horizontal line on top, then your time period will follow a certain vertical line there on your left hand side. That's what the time period is. So where 6 and 10 meet, so it will be like this. Let me just illustrate it a bit. So like you have your 6% there on the top part, then your 10 years will be this side on your left hand side of the table. So where these two lines meet like this, that is the point, this point here, that's the figure we want. So you'll find that when you use that table, the PVIFA table, you should get 7.3601. So when you now multiply this, you get a final answer of about 18,400.25. So this is your answer that you have computed. Remember, you're trying to check which one is what? Worth more now. You've been offered a 20,000 lump sum. What lump sum actually just means is that you're being given a 20,000 all together at one go. And then the other this is now the other option of being given an annuity of 2,500 for a period of 10 years. But the thing is that we are trying to just discount it to the present because they said which one is worth more now. So we have done that and it's given us 18,400.25. So if you make a comparison, which one would you pick? Most likely you would go for the higher one. Why? This is because you would want to get a higher return than a lesser figure like the one we just computed. So therefore you just write this and say the theoretical statement that you're just going to say is that I would go for the higher one, which is the 20,000. Yeah, so just say you go for the higher one, which is the 20,000 lump sum. Yeah, then you just maybe just add my last sentence that because it is more than the annuity of 2,500 when computed. So that's all. That's how you just handle that question, and you get all your full 10 marks that were there. Let us look at the next question. This one is saying you borrowed 20,000 to be repaid in 12 monthly installments of 1,891.20. What is the annual interest rate? So looking at this question, you have to ask yourself, what formula will I work with? So most of the time when you've been told borrowing, take note of this. When something to do with borrowing, we always refer to the present value. Why? Because we look at the moment that you have been given that money to borrow. That's why we always go back to the present. So we're going to use the present value. So if you look at this information, what have you been given? You've been given the amount you've borrowed, 20,000. This 20,000 is in which? Is it in the present or is it in the future? This 20,000 is actually in the present because you have just borrowed. That's why I said you borrowed 20. So this is the present value amount. Then what else have they asked you? They told you that you'll be paying this back in installments, 12 monthly installments. So it's been compounded monthly. So when you compound something monthly, it's like your periods now change, to now you're now looking at 12 periods of 12, yeah, because they've compounded this monthly. So even when you go to your table, that's a PVIF table, you should look for period 12. That's the one you go for. And then what else have we been told? Annual interest rates needs to be calculated. If you read this part, what is the annual interest rate? So we know that we're using the present value formula. So let me write that down. So we said we're using the present value formula. So PV is equal to, so when your PV is the subject, you have your FV inside and this, the PVIF. So just take note of this Katrika. When your subject is PV, most of the time you find that your interest factor table will be also a PV. So that's just how we just remember these small tips. Yeah, and remembering the formulas. So we've been told that you are given a 20,000. You've borrowed. That money, we said it's in which tense? It's the present. Why? You have just borrowed. So you put the 20, you substitute what is a PV. Equal to what? Do you know the sorry. This is it's an annuity. Let me just correct that. I've just realized that they said 12 like equal monthly installment. You'll be paying that 1/8 each and every month. So if it's a fixed month that you're paying each and every month, that's entails that this will also be an annuity. Let me just correct that, sorry. So we are using this formula. So PVIFA. Yeah. So we have the annuity of how much? 1891.20. So that is how much you are paying should I say what? Per month until the 12 month period, because they've compounded this monthly. And you are looking for what? Your R. Is T known? Yes, they said 12 periods are compounded monthly, so our periods have changed to 12. So the thing is that if one of those two are missing, if either rate or time is missing, this interest factor thing, PVIF, it's never computed because one of the essential elements to it is missing. You can only get the value of this PVIFA or any other interest factor value if the rate and time are known. So like in this question, they were not. So what you're going to do is you're going to change the subject to the formula. You can divide both sides by that and the other side by the same thing. And then after that, you now make that the subject. So you'll find that your subject is going to give you, let me just divide that properly. I think you should get 10 point So you get 10.5 something, yeah, if I'm not mistaken. So after getting that value, what next? And of course it should be equal to what? Your PVIFA, because we said it's not known because rate is missing. So what you're going to do is you go to your table, look for that value, and you should get a value. Just a minute, let me just confirm with my table as well. Okay, so this should be about 10.5, as we said that when you divide that 20,000 by the 1.8, so it should be actually 5.7 something, 5.76, somewhere there. Then you go and look up this on your table using what will guide you. The only element known, it's time here. So the timeline will guide you to locate the rate value that you're looking for. So if you use the time, is it the row that the timeline of 12 falls in, you follow it until you find this figure here, the 10.576, then you get the rates that drops there. So you find that it should give you a rate of about 2% there. That's the answer. So, and then you even say, okay, your R is equal to 2%. Then you're done. Just like that. Okay, the next question now. The next one is question 7. Your favorite uncle has offered you the choice of the following options. He will give you either 2,000 1 year from now or 3,000 4 years from now. Which would you choose if the discount rate is 10%? Just from this question again, we've seen something similar to the first question we started with in this video. Your favorite uncle has offered you the choice. So you're making a choice at some point. So as earlier stated, we've been given a question with where you have been given a choice, something to choose from. Always give a theoretical statement after that. You write a certain sentence saying, okay, I'm going to go for this option. That will be the only way you get the full marks. So you've been given two options, a 2,000 1 year from now and a 3,000 4 years from now. If you look at, let's start with one at a time. Let's start with the 2,000 first. This 2,000, is it in the present or in the future? This 2,000, if you look at it, they said 1 year from now. It's not in the present, it's in the future. So what we're trying to now do here is that we're trying to choose the best option. So most of the time when you've been given money in the future and you're being asked to choose from it, we usually bring it back to the present. Just take note of that. So like in this scenario, what we're going to do is we'll bring this 2,000 to the present, bring the 3,000 as well separately to the present, then we compare the results. That's what's going to happen here right now. So let me just do that, and let's get the possible values. So we said you've got let's start with the 2,000 first. So it's in the future, right? So we are trying to bring it to the present. So we have used the future value formula. Reason being, the figure we have been given here is in the future. It's like something being equated to in the future, 2,000 2 years from now. So we don't know the PV there. Okay, what is this part? The FVIF. So we have a rate. They are given a rate 10%. Time period, they said 1 year from now. So just go there and put. We find it on the table. 10% 1 year from now will give you a certain figure like this, I'm sure. So then you now like change the subject of the formula where you divide both sides by 1.100. You should land with a final answer of about 1.88. 1818.18 kwacha. Okay, the next one, you also solve this separately as well, the 3,000 as well, to be like in the future. Yes, then you have your PV, and then of course FVIF. When your subject of the equation is like for example future, your interest factor also be future. It's not an annuity, so we are not including an A. So again, this one is in 4 years time, right? So let's try to bring it to the present. We don't know the PV. If you go to your table, look for the value of FVIF there in a period of 4 years, because they said 4 years from now, and a rate of 10. You should get a certain value. I think was that is it 4 point something, if I'm not mistaken. Yeah, but you should get a final answer of about this 2049. Yeah, point something. That's the answer you should get. So remember, you now have two figures, huh? You have that one and you have this one here also, 1818. Then they ask you, which choice would you go for? Of course, you would want to go for the higher one, huh? Which is the 2049. Why? It yields a higher return. So you would just write a small statement there saying that I would choose the 3000 due in 4 years, because that's how the question came. So it's like you repeat the same words you've used. Yeah, so the 3000 that you had completed is the one which is bringing a higher return. So you just repeat the same words and say, okay, I will choose the 3000 that is due 4 years from now. 4 years from now. Yeah, something like that. Then at least you've answered the full question there. You can look at the next question. Part B. If you need 6,000 5 years from now, how much of a deposit must you make in your savings account each year, assuming an 8% annual interest rate? If you need 6,000, have you heard this question? If you need 6,000 5 years from now, how much of a deposit must you make in your savings account each year? So let's analyze the information. We want to know what formula we'll use, what terms are we dealing with, and the like. So you need 6,000 when? 5 years from now. So now they're asking how much must you deposit to make that 6,000. So it's like whatever you should do now should be equal to what? 6,000. It's like all your computation, like whatever you must deposit today should come and equate to what? 6,000. So from that theory, you make an equation saying that whatever our compute should be equal to the 6,000. So knowing that the 6,000 is what everything should be equal to, what tense is the 6,000 in? Is it in the future or is it in the present? The 6,000 actually, if you look at it, they said 5 years from now. It's actually in the future. And we said that whatever we're doing should like equate to it, meaning the future value of 6,000 is the subject of this equation. You've analyzed it like that. So that's how usually we denote which formula we use, just by that kind of reasoning. So we'll put this back in our formula. So we have that 6,000, then we've been asked how much must you deposit to make in your savings account each year. Is this an annuity? Yes, the keyword there was what? Each. So just from that we can analyze that, okay, definitely this is an annuity, and we know the formula we're going to work with will be future value, because we said the subject is future value of an annuity. So we said future value. Just quickly I rewrite that. Future value of an annuity, as we have analyzed there. Okay, so we said this is the formula we're working with. So let's substitute what we have. So we have a 6,000 that we want to equate to in the future. 6,000. Let's rewrite that properly. That, and that. Then the annuity is what? Do we know the annuity? No, because they said how much must you be depositing? That's what they told us each year. We don't know. So it's going to be A. They didn't tell us. Then what about this other part? FVIFA, the interest factor of an annuity. So what have we been given? You have been given a certain time period, which is 5 years. If we look at the rates there, it should, I think, be 8. Let me just reconfirm that on the time. The interest rate actually is 8%. That's what I was actually looking for. So the time is 5, interest rate is 8. So when you do all your computations as well for this question, you put in a certain value for your FVIF, you'll find that it should land you to 1022 as your annuity payment. So it's like you have found how much you need to be depositing now to lead you to what? To that futuristic value of 6,000. So just like that, you have computed. So the next question, let's look at it quickly. This one, part C, says a 1 million kwacha bond issue is outstanding. Assume deposits earn 8% per annum. Calculate the amount to be deposited to a sinking fund each year in order to accumulate enough money to retire the entire 1 million issue at the end of 20 years. So this question, when you see sinking fund, most likely that's the one which is eye-catching, the sinking fund. So the sinking fund here, in this case, it's actually an application of the future value. So just take note of this. Sinking fund is application of future value. So already we know the formula we're going to work with, because sinking fund is an application of future value. And what is this question about? It is talking about something to do with each year. So it's an annuity as well. So we're going to deal with future value and of an annuity. Then further, just to even supplement that, for sure this is a future value, they've added the word that in order to accumulate. If you just reason on this word, can you accumulate something in the present? Of course not. So most of the time when you're accumulating something, it's in the future. So those are the keywords. You look out for pointers, but of course just know that the sinking fund is an application of future value, and we are using the future value in this question. So what we're going to do as well, we'll do the same thing for this one. I'll just state the general formula again. So it's future value, of course, of an annuity. So we've been told the thing is, how much should we be putting each year? So again, the annuity is not known, because they're asking us how much should you be putting. Then this is the formula we're working with. So always in corporate finance, state the formula before you solve. This is just the standard. If you really want to get your full marks, follow the standard. So that's that part. And then now, what have you been given? You want to gain 1 million at the end. So you've been given a certain future amount of what? 1 million. So you write the whole 1 million here should be equal to the A, which is not known, multiplied by that FVIFA. What rate are you using? 8%. Time period, 20 years. So you would go to your table again, future value interest factor table of an annuity this time, and then look for R and T, the 8% and the 20, where they are meeting, those two. Then you get the value that is there, and you compute the value of this sinking fund. So later on I'll just share the answers, of course. Then now part D, let me just read D quickly. Part D says a bank offers to lend you 25 million to buy a second-hand car. You must sign a loan contract calling for payments of 2,545,1,060 at the end of each of the next 25 years. What rate of interest is the bank offering you? Yet again, we are being asked to calculate R. R is missing the rate. And then, what is happening in this question? You have been lent. Lending, borrowing, that word. So we said when you're talking about anything to do with like borrowing, this is an example again of present value. This is like an application of present value as well. Just like we talked about sinking fund is an application of future, borrowing is an application of the present value. So what details have you been given here? So what you can now go and substitute. You have a 25 million. We also have 25 million which you've just been lent today. So that's your PV. Then if you look at the next one, you must sign a loan contract calling for payments of 2,545,160 each year. Is this an annuity? Yes. So you know the formula going to work with is as follows. So you're going to work with that same formula which we just earlier stated, present value. We said it's an annuity, so you do that. PVIFA. This is the formula you're going to use. So what is your A? Your A is the annuity, which they said is 2,545 there, 160. What is your PV? They said you have been lent 25 million. So that is your current money, present money. So you write the whole 25 million. Sorry, just for my space here, but you write the whole 25 million. And then you equate it to that, then your PV IFA. So can you easily find the value of the PV IFA? No. Why? We said if one of the components, which is either R or T, if one of them is missing, you can never know the value of this until you make the PVIFA the subject of the formula. Then now you go and look up the missing item. In this case, it's rate. So after you do that, you change your subjects of the formula. You should land. Let me just calculate that as well. So there, that's my calculation. When you divide. So that answer was just shown on the screen. That is the answer after you do your computation of 9.2, just a minute, 8226. Yeah. Then you can look this up on your table, this figure. Remember, we've made your PVIFA the subject of the formula, right? So you are trying to look for the rate which falls on this figure, but you know the time. The time period is 25 years. So it will guide you that 25-year line there on the time, and you move along that line until you get this figure or something really close to 9.826, and then that is your rate. In this case, it drops on 9%. And that's the answer. So those are the solutions and how to calculate those few questions. Okay, so solutions as well will be sent.